Welcome back. This is the very final problem that I want to discuss. And if you really solve this problem after I have you pause and try to solve the problem, then you can truly take credit that you have understood everything, those nuances we've learned in 170. Okay. And this problem is a real testament of how well you can think, how strategically you can think, infusing various problems, various concepts into solving a problem. Okay. Now, everything in this problem, well, except for the Raoult's law, which is a new equation that, again, you don't need to remember it. I'll give the generic Raoult's law on the appendix. Except for that, and then taking this new idea and reinventing or going back and trying to take knowledge from basically 170 and solve this problem is a real testament of what you can do, right? All right. So whenever you see, first of all, the term vapor pressure, and in this case, we clearly said grams of a solute, which is non-volatile compound B, added to 250 grams of water. So we're adding a solid to a liquid. So essentially, we're going to say the P total equals the vapor pressure of whatever. You can do it for the solute or for the solvent. But I'm going to write solvent here just for the solvent and vapor pressure of pure solvent. You would wonder, why do I not do it for the solute? Because you're only given the vapor pressure of the total mixture, the solution, and the vapor pressure of water. Okay, you really have to, you can only do if the vapor pressure of water is given, which is a solvent. Water is a solvent. Okay, so it's really ideal if you can do the mole fraction of the solvent. Okay, now if you go back and watch the first problem I did and compare to this problem, then it would make more sense as to why I'm solving for the mole fraction of the solvent. Now at this point, you can pause the video and see if you can actually solve the problem. Okay, once you write this equation from here, your brain should search for information from 170 and see how I can solve the problem. Essentially, you're asked to find the grams of your solute. Okay, that's in a nutshell what the question is asking you to do. Anyways, the total vapor pressure of the solution is 23.756 torr, which equals to the mole fraction of the solvent, which we don't know, and the vapor pressure of the solvent is given to you, which is 42.362 torr. Okay, so let's solve for the mole fraction of the solvent. Which happens to be, so mole fraction of solvent equals 0.5607. Okay, now as I said, mole fraction does not have a unit. Now the question is, we have to find the moles of the solute using the mole fraction of the solvent. So let's write that equation I gave you. Mole fraction of the solvent equals moles of solvent. I mean, like I said, if you can solve this problem without after you pause the video and look it up and you think you got it right, then that shows a real testament of how much you've understood out of 170. Okay, this is the mole fraction of the solvent. If it's for the solute, then it will be solute. So the mole fraction of the solvent, which we already know is 0.5607, we have to find this. Then knowing the molar mass of the solute, we can find the mass of the solute. Remember, that's 170 material. But we have to still find the moles of solvent. Well, that's no problem. We know the mass of the solvent is 250 grams, and the molar mass of water is is 18 grams over 1 mole, which is around 13.88 moles, right? So now we know the moles of solvent. So that will be, we know the mole of solvent is 13.88 moles over, let's call it X for now, which is moles of solute plus moles of solvent is 13.88. If you solve for X, which is just merely algebra, so it'll be 0.5607 X plus 0.5607 times 13.88 equals 7.78 moles equals 13.88 moles. Now, to actually find the X value, you just have to subtract 13.88 minus 7.78, which is 6.1 moles divided by 0.5607, okay, which would be is 10.888 moles. This right here is the moles of the solute. Now you know exactly what to do. This is the moles of the solute. Now that's your given information multiplied by the molar mass, which is 97.80 gram over 1 mole. Okay, so that would be times 97.80. So it will be 1063 grams. There you go. Now let's quickly analyze the problem, and I can tell you exactly where you'll get missed out is, well, the generic equation for Raoult's law is the total equals, you can use mole fraction of solute times the vapor pressure of solvent, or this is always solvent, okay? This term will always be solvent, but right here, you can do it for mole fraction of solute or mole fraction of solvent. In this case, because we know the vapor pressure of the solvent and we know the total vapor pressure, and because we only know the mass of the solvent, it's just you've got to look at the problem in a much more broader sense than try to use. If you had used solute, you're not going to go anywhere with the problem, okay? You just won't be able to go anywhere with the problem because, again, what are you going to do with it, right? So this is the only way you can solve this problem. I don't know if you can put solute here and you'll be able to solve the problem. So what I want you to do is when you finish this problem, write down what are the things you understood or not understood, and then compare this video to the very first video where we did mole fraction of the solute, okay? Then you would read both questions for both problems and then see how is one problem different from the other. You must be able to dissect a problem and understand when to use what. And if you don't understand that, no matter how many problems I do or you do, you would never be able to actually figure out or decode the solution on how to go about solving the problem. Now this, after we got done right here, the rest of it is all 170, okay? Now you may have forgotten, you may remember, but it's important that you understand everything we've done in 170 is not just the end of the story, it's going to continue, okay? And that's why I taught you the entire material on a concept map curriculum design, because everything is tied to everything. You just cannot just get rid of something and hope that you would still be able to do the problem. Sorry to say, but that's just not how things work, at least in chemistry. So I'm going to stop here, and then when I come back, I'm going to start the concept of elevation of boiling point and then freezing point and then osmotic pressure. All right, so stay tuned.